Osgood Industries is a leader in designing innovative machinery for filling consumable products in various containers. The purpose of this design is to fill plastic cups with fruit and yogurt. The process begins by automatically feeding the empty container, sanitizing, and the filling station. Next, the lid is applied and sealed. The seal requires significant heat and pressure during this stage. Let's take a closer look. The actuators above are pressing the seal with a large force. And it's important that the support underneath will handle the load, not just once, but thousands of load cycles per day. In the past, the design team would simply over-engineer the components, but with the increase in material costs, that is no longer a luxury. It is also difficult to rely on tribal knowledge as customers are constantly asking for higher capacity machines, more throughput forcing changes in every design. Nastran in CAD is fully integrated in the CAD design environment. We are notified to check the assembly or parts out of the vault in case we decide to save any changes. And the analysis uses material information from the CAD model. We can then begin describing the behavior of the assembly. How is it held down, and where are the load conditions applied? Constraints can then be used to simulate the 4 locations where the fixture is attached in the main assembly. And we have the load that is coming down from the actuators and the fixture above. In just a moment, we will observe the impact of these forces on the stress and displacement of the assembly structure. Now we can mesh the assembly or break it up into several pieces to be analyzed, and finally solve, which takes less than 2 minutes. There are several results that are available to the Osgood engineering team, such as the stress information. The maximum stress value is about 160 megapascals, which is fairly high, but will the material fail? Directly in the graphics view, we can quickly select the other types of plots in an effort to answer that question. Using a factor of safety plot, we can compare the stress to the yield strength of the stainless steel. By adjusting the legend, we can focus on areas that are below a value of 10. The worst case we are looking at is 2.5, which many times is considered a good design and mistakenly move on. Using Autodesk, the designer not only determines whether the structure will handle this load, they are also able to predict how long the parts will last in months or years. This in turn will greatly reduce warranty costs for the components and unexpected downtime for the machine, which frequently runs 24 hours per day. After changing to a fatigue study, the load we use now contains an additional option to specify the behavior of the load. Is it fully reversed, or is it simply loaded and unloaded in the case we have here? Also take a moment to make the results more meaningful. Rather than finding the amount of loads, we are told how many months the design will last using a time conversion factor. There are 2 result plots that we are interested in. The solid damage tells us how much of the life is taken for each load. We can also view the solid life, which tells us how many months the structure will last. In a few locations in the design, we are seeing just under 2.5 months, which is of course not near the performance we are looking for out of this machine. The power behind Autodesk Nastran in CAD is the ability to make changes to the model and run the analysis without leaving the design environment. Let's add 1/4 inch to the diameter of this shaft in an attempt to lower the stress. Now that we have modified the design, we will update the mesh and solve. Back in the results, we will take another look at the life of the support structure. It is determined by the analysis results that the new design satisfies our requirement for an infinite number of loads. The engineering team can now confidently move on to other areas of the design to focus on. The advantage here is the structure was tested in a matter of minutes to find out whether it would last for months or years. The engineering team saved time on physical testing, expensive material, and on time-consuming rework due to warranty claims during use. Finally, the engineer can communicate their findings with the rest of the team while checking the new version into the vault. Design, test, manage, and collaborate in one familiar, easy-to-use environment.